I'll be presenting a series in mathematics that has to do with the basics in mathematics. And now this is to help everyone. It's to help the junior student, the high school students, it's to help the students who are in the college, the university, masters, and to whichever level. These are the basics that is necessary for physical sciences, biological sciences, and every part of sciences. It is a series, and it has to do with what you need to know in mathematics. The first thing I want to discuss is what we call powers, exponents, and bases. So I'll be discussing powers, exponents, and bases. This is what you see every time, and this is what we work with every time. But sometimes we do not know the rules that govern these properties in mathematics. For instance, I'm sure you've seen something like 2 raised to the power of 3. So the number written up here is a power, and the number written here is what we call the base. So this can also be expressed as 2 times 2 times 2, and that gives us 8. So what I'm trying to say in essence is that you will see P or n raised to the power of P. It means the multiplicity of n, the multiplicity of n in P places. In P places. So we have m times n times n in P places. So P times. P times. So we need to know that. So if I connect this with other bases, what happens? So what happens if I was to have the first rule is what happens if I have a raised to the power of n times another a raised to the power of n. So what happens if we connect this? What happens if we divide something of this nature? What happens if this happens? So the first thing you should look at is the bases must be equal. So we have equal bases. And once this happens, the next thing we should look out for is the multiplication symbol. And once we have this, we can comfortably add the power. So what this rule is telling you to do is, number 1, multiplication. Number 2, the bases. So remember, this is the base, 2 here is the base, 2 here is the base, also here m is also the base. So take note of the base and take note of the exponent. So like here, this is the power, or what we refer to as what the exponent. So in this case, this is multiplication, this is division, and we have the same base. Please take note of that. If that happens in this case, we are supposed to subtract the powers. So in this case, we add the powers because this is multiplication and we have the same base. In this case, this is subtraction of the power. So n minus n. We subtract the powers because of the division symbol here. Please, this rule or these axioms, these are actually axioms, only work if we have the same base. So please, there is a caution. You're not supposed to have 3 raised to the power of 2 times 2 raised to the power of 5. This rule does not apply here. So some students may do that mistake of multiplying this by this and having something like this. Please, it's a big no. It's a big no. You don't do this. Instead, what you do is to solve them independently. This will give you 3 times 3, and this will give you 2 times 2 times 2 times 2 times 2. This is 9, obviously, and this is what? 32. And you can now multiply that to have your answer. So that is how that is done. So please, this can be solved this way. You can only apply this if you have something of this nature. You have 3 raised to the power of 2 times 3 raised to the power of 3, and that will give you 3 raised to the power of 2 plus 3, which is 3 raised to the power of 5. So this is when you use this. This is when you think about this. You smile. Now, we come back here. What if these bases are the same? What if we have a raised to the power of n and a raised to the power of m? That is going to give us a raised to the power of m minus m. So by this rule, having this same base, we can subtract this, and we have m minus n, and that is going to give us a raised to the power of 0. And what will that be? Anybody will wonder. In mathematics, if we are to divide two things that are equal, like 5 divided by 5, 20 divided by 20, 60 divided by 60, it gives us 1. So the same thing happens here. This is supposed to give us 1. So that also proves that this is going to be 1. So that is why you have any number raised to the power of 0 is equal to 1. Please, any number except 0 itself. So any number you have, maybe like 26.39 raised to the power of 0 will give us 1. But please, 0 raised to the power of 0 is not 1. Please, so take note. So that's why when we say any number, we say except 0. So every number will give you is except 0. So take note of this. These are the 3 basic principles. In the next video, I'm going to be discussing the next 4 principles that take their roots from here, and you can use that to solve basic problems. But I will round up by introducing this. I will use this part of the board, and that is number 4. I will discuss the 4th rule here. And the 4th rule is simply saying, what if we have this and we still have another power outside? So what I'm saying is we have something like maybe 3 raised to the power of 2, and we have all this raised to the power of 5. It's simple. All you need to do is to multiply those 2 powers. And we have 2 times 5, and that gives us 10. So this is what this rule says, and this is what you can also think of here. So this simply tells you that you can multiply the powers. So this is the 1st, the 2nd, the 3rd, and the 4th rule. Just have that in mind. You can use that to solve a lot of problems. Not just this. What if we have A over B raised to the power of C? We can also have A raised to the power of C over B raised to the power of C. So this A can have this C as a power, and B can have this as a power. In the next video, I'll be talking about the other rules, and I'll be applying them to solve a lot of problems. So check out for the next video. Thank you.